Assalamu alaikum viewers. In this series we are covering second year physics chapter 12. In this video we will cover potential at a point due to point charge. It's a long explanatory question of 5 marks, appeared frequently in different papers of boards. Now let's start. Now consider it's a charge Q and we have some electric field around it. Our target is to find electric potential at this point. To calculate electric potential, we need to bring a unit positive charge from infinity to this point, keeping the charge in equilibrium. To find potential at point A, we use this equation del V equals to minus E del R, which we derived in previous topic. Here we find potential difference between 2 points, but one of the point is at infinity where potential is 0, so we get a single potential at point A. But this equation requires that E must be constant throughout the region. But here electric field does not remain constant and it increases as we move towards charge. To resolve this issue, we will take these 2 points very close to each other and then we will apply this equation to find potential difference. Now consider that A and B points are very close to each other and their separation delta R is very small. So we can say that electric field remains constant between A and B. If RA is distance of point A from charge Q and RB is the distance of point B from charge Q, then we can write delta R equals RB minus RA. So here we write this equation delta R equals to RB minus RA. Now consider a third point in between A and B. Suppose that it is a distance R from the charge Q. As R is between A and B, so we can say that R is arithmetic mean of RA and RB, and we can say that RA plus RB divided by 2 equals R. Now if electric intensity at this point will be 1 over 4 pi epsilon naught Q over R square. To keep electric field constant, we assume that points A and B are very close to each other and delta R is very small. By this approximation, we can say that geometric mean of R and arithmetic mean of RA and RB will be same. First we will find geometric mean of these. Let's look at this example of geometric progression. In geometric progression, each term can be obtained by multiplying previous one with a constant. So if we divide each term with previous term, we will get same constant. As we see in example, 15 divided by 5 gives 3 and 45 divided by 15 also gives 3 and so on. Now if RA, R and RB are in geometric progression, then we can say that ratio of R to RA will be equal to ratio of RB to R. Thus we write here that R over RA equals RB over R. From this equation we get R square equals to RA RB. Putting this value in equation 1233, we get electric intensity equals 1 over 4 pi epsilon naught Q over RA RB. Now writing again the equation, potential difference equals to minus E delta R. First multiply the negative sign inside the brackets, so we will get RB minus RA. Now putting values of electric intensity and multiplying inside it, we will get. Now we will put values in this equation. E equals 1 over 4 pi epsilon naught Q over RARB, and in brackets we keep the same RB minus RA. Now multiplying this denominator within brackets, we get RB over RARB minus RA over RARB. Now if we cancel these terms, we are left with 1 over RA and 1 over RB. So we write this equation here. VA minus VB equals Q over 4 pi epsilon naught into RB minus RA over RARB. Now after cancelling, we get 1 over RA minus 1 over RB. As we want to calculate potential at a single point A, we have to imagine the point B at infinity. If we take point B at infinity, RB will be equal to infinity and 1 over RB would become 0. Putting in this equation, we will get VA equals 1 over 4 pi epsilon naught Q over RA. Now if we drop the subscript, as we are left with single point, so there is no need to write ABC. The equation become V equals 1 over 4 pi epsilon naught Q over R. This equation gives us potential, electric potential at a point which is at distance R from point charge Q. If the charge is negative, we will put minus Q and we get negative potential for negative charge. It's a scalar quantity, so there is no need of unit vectors here. With examination point of view, it is an explanatory question of 5 marks frequently appeared in past papers of different boards in Punjab. So now practice it yourself, and if you have some problems, you can mention it in comments. Thank you.